Hi there, welcome back. So you might be asked a probabilistic question, not about something happening, but maybe about something not happening. How would you answer that question? Well, it turns out it's pretty simple, and it's called the rule of complements. Let's see how it works. Let's say that you've got this group of people, Angie, Bruce, Catherine, Dave, all the way alphabetical down through Jack. And rather than asking you, what's the probability that you pick Jack? Like if you're picking a person at random, what's the probability that you pick Jack? Which we can see is 5%. What if you're asked a different kind of question? What if you're asked, what's the probability that you don't pick Jack? You pick somebody and it's not Jack. So what's that probability? Now, I hope it's kind of obvious. You're going to be picking somebody. Now, we don't know who, but 100% probability you're picking somebody and 5% chance it's Jack. So it's got to be 95% chance that it's not Jack. So if your question is, what's the probability you pick someone and it's not Jack? It's, it's just 100% not Jack. Oops. And that's a whole lot easier than what some people are sometimes tempted to do. For example, if you're used to situations where you're looking at all the possible outcomes and adding up all those outcomes, well, there's so many different ways that it could not be Jack. Right? It could be Angie, it could be Bruce, it could be Catherine, Dave, Eddie, George, Hoda, and Ingvar. So like a brute force method would have been add up 10%, so 10% probability of Angie, 18% of Bruce, 2% of Catherine, 19% of Dave, 21% chance of Eddie, 13% chance of George, 7% chance of Hoda, and 5% chance of Ingvar, and then you got to add them all up. And man, it's easy to make mistakes like that. I'm not sure I wrote this down right just now. You'll have to look and tell me. But I can make mistakes. You key that into a calculator, and mistakes are likely. It's a whole lot easier, rather than brute forcing it, to just use the rule of complements. It simplifies things. Here's another slightly more formal way of looking at the problem. The complement of an event is defined to be the logical complement, the idea of everything but the thing. So if A is the event, the logical complement of A is anything that isn't A. I don't care what it is as long as it's not A. And notation varies a whole lot depending on which textbook you use, which professor you have, what day of the week your professor happens to be lecturing on. The notations are varied, but they're also so common that folks kind of flip in and out of notations probably without even realizing it. I know I'm guilty of that too. So you'll see some common notations are A with a prime, A with a superscript C, C for complement. Just got to remember that it's not an exponent. For folks that are kind of into computer programming, you'll see an exclamation mark for a not. So you'll see like not equal when you're doing some kind of logical relations in computer programming. And then it's also common to see a little tilde, A, for not A. So as the example, if A is the event that some coin flip comes up heads, then everything else, well, it can only be tails, right? So the logical complement is tails. If you've got here this Venn diagram type thing of all of the possible different things that could happen and their probabilities. If the probability of heads is 80%, then what's the probability that it's not this? Well, if the entire box, like the whole thing, is 100%, and 80% of it is this shaded brown area, then that's got to mean that 20% is the part that's left over. Right? So that really just brings forth a very obvious formula. That if you're asking what is the probability of something not happening, it's 100% minus the probability of the event happening. Right? So 1 minus the probability of A. It's equal to the probability of not A. Right? Just a final example, just to close things out. Let's say that you've got a dice, but it is, it's a 6-sided dice. What's the probability of rolling a 2 on a 6-sided dice? That's just going to be 1/6. What's the probability of not rolling a 2? Well, I could add up, I could do this the long way. So, so there's a 6th probability of a 1, a 6th, a 6th, a 6th, a 6th, and add up all of those and I get 5/6. Or I could just use the rule of complements and say that it's 1 minus the probability of a 2. So 1 minus a 6th gives us our 5/6. So it's kind of neat. It's very powerful. You'll use it a lot. Thanks for listening.